Welcome to Finvidyaa. This is Aditya Pathak, and today with me you are going to read about the Poisson distribution. So the first question, that is, what is Poisson distribution? So the Poisson distribution is a probability distribution that tells you the chance of certain number of events happening in a fixed time, space or region. Okay, and when those events happen independently, that is, one event does not affect the other event, right? And the second point, happen at a constant average rate, say that is average 5 per hour, okay, and are rare or discrete events. It is countable and not continuous like height or weight. So in simple terms and simple words, what Poisson distribution aims is like how likely is it that something happens x times in a given interval. For a very classic example, let's assume a crossover of road. Okay, and in that crossover or a turn, what is the chances that exactly 5 accidents will happen in let's say 8 hours of time span. Okay, so if this kind of problems arises, then we need to use Poisson distribution to find the probability that how many accidents will happen at that particular turn in a time span of 8 hours. Okay, so let's move forward. So why do we need Poisson distribution? As I told you just now, that very classic example, in the road's turn, number of 5 accidents happening in a time span of 8 hours. If these kinds of a situation arises and we are asked to find the probability of that is where we use the Poisson distribution. Because in real life, many things happen randomly but with a predictable average, right? The accidents will not happen, means it is not a continuous process and it happens randomly, but there is a chance that it can happen, right? So we cannot say that exactly when that event happens. Like in my example, that accident in the road's turn, it has a great amount of chance that it can happen, but we cannot say exactly when. But when we can measure how many times it happens in a given interval, okay, it helps model rare events, things that do not happen every second but still follows some pattern to it. Okay, so for example, if a call centers get 10 calls per hour on average, so the Poisson distribution can tell us what is the chance they get exactly 12 calls in an hour, okay, or the chance they get no calls in 5 minutes. Okay, so this Poisson distribution, it is useful for forecasting probabilities when randomness plus averages combine or are involved together. Okay, so coming to the definition of probability distribution or the Poisson distribution, it is a discrete probability distribution that expresses the probability of a given number of events occurring in a fixed interval of time or space, provided that these events occur with a known constant mean rate and independently of the time since the last event. Great, let's move forward. So talking about the probability mass function of Poisson distribution, we have this formula, that is Px equals to k equals e to the power minus lambda into lambda to the power k by k factorial. So the capital X over here is random variable, number of occurrences, k is number of occurrences, lambda is average rate of occurrence, that is the mean or the average, and e, it is assumed to be taken as 2.718. So for the Poisson distribution, it is really very important to note this, that mean and variance are equal to each other for the case of Poisson distribution, right? That is equal to lambda. So if in the case we are asked to plot the graph, so the shape of the graph depends upon the lambda. If lambda is small, the distribution is skewed to the right, that is more weight on the lower values. And if lambda is large, the distribution becomes more symmetric and approaches the normal distribution, that is of a bell-shaped curve. Okay. So this distribution gives an approximation of binomial distribution values in case P, that is probability, is very small and N is very large, that is greater than 50, so that NP remains the same. So in general, Poisson distribution can be used as an approximation to binomial distribution with parameter equals M equals NP. Okay. So Poisson distribution is a limiting factor to the binomial distribution, right? So for our case, to understand this concept more clearly and to implement it practically, we have taken a small question that is a very classic example to understand the theoretical part of this topic. Great. So it says, in a certain manufacturing process, 2% of the electronic toys produced turn out to be defective. So 2% of the electronic toys produced turn out to be defective. What is the probability that a shipment of 200 toys will contain exactly 5 defective toys? Also, we have been asked to find the mean and the standard deviation of the distribution. Great. So this question explains a classic example of Poisson distribution, that we have been told that out of 200 toys, what is the probability that 5 will be defective toys? Great. Let's move towards the solution. So we have N equals 200, that is the total number of toys manufactured. Probability of a defective toy is 2 by 100. It equals 0.02. Great. We apply the Poisson distribution formula, this particular formula, and probability of 5 defective pieces in 200 toys. So definitely we are targeting that there will be, what is the probability of 5 defective pieces? So probability of 5 e to the power minus lambda, lambda to the power 5 by 5 factorial, where lambda equals NP, that is 200 into 0.02, that is equal to 4, and constant value is 2.7183, right? So upon, if you just put the values and calculate, we get that the probability that 5 toys will be defective in the lot of 200 toys is 0.156, right? And talking about the mean, that is NP, it is equal to 200 into 0.02, that is 4, and the standard deviation, that is root over NP, that is root over 4, that is equal to 2. So we have found the probability, we have found the mean, we have found the standard deviation. For your better understanding, I'd like to repeat this question once again. So we had total number of toys 200, probability that 2% is defective, that is that 2%, that is 0.02, are defective in every lot. When we apply the Poisson distribution formula, this particular formula, so if we put the values, we get this particular equation where lambda equals NP, that is 200 into 0.02, that is 4, E constant value we are already given. So final equation comes out to be this particular equation, that is P5 equals 2.7183 to the power minus 4 into 4 to the power 5 by 5 factorial. So if you solve this particular equation, you'll get this one, that is probability that 5 toys are defective out of 200 toys is 0.156. Mean already we have got earlier, right? That is 4. And standard deviation is 2. Great. So thank you for watching this video. I hope that this class would have helped you with Poisson distribution. Thanks for tuning in to Finvidyaa. Please like this video, share with your friends, and subscribe to Finvidyaa for such videos in the future. Thank you.